Now, I would like to invite Mr. Sandeep S Nair, a leader with over 17 years of IT industry experience across a wide spectrum of areas of software product development and delivery. He was a senior product manager in IBS and director in Conclave Labs. He is currently running an AI-based startup in Trivandrum.
We'll today discuss briefly about Web 3.0. It's a huge topic, but I'll try to compress it a bit and then we can discuss it first. Anyone have any idea about Web 3 or blockchain? Have you heard of it at least? Yeah, okay, that's good. Yeah. So basically, Web 3 refers to, we can call it as a new generation or new phase of internet development. Like if you look at how the web developed, initially it was a read-only thing where we can just see things. There is no way to interact with it. But as the time goes by, it got changed into something that we can interact. Like we can create blog posts, we can create our feeds, we can create form submissions and all those things. So slowly it became sorry, nothing will happen. So slowly it became the way in which we can interact with it, and then the next phase. But the problem with the previous phase, like when we interact with the web, what happened was that we need to depend on some third party. Third party meaning third parties like huge companies like Google, Facebook, and all those things, where we will share data with them, and we don't know what are all the data they are collecting, and they will use all these data. And then they will use the data, they will sell it, and they will use the data against us also sometimes. So that is the risk with this previous generation of web. And when we move to Web 3.0, the advantage is that we can read, we can write, and then we can own the data. That means we create the data and we own it. There is no third party or middleman. That is the advantage. Okay? Okay. Yeah, so of course this 3.0 is backed by blockchain technology, and I'll briefly discuss about this blockchain, what it is, and then what are all the different components and all of those things. Yeah, this is the thing I was talking about earlier. Like initially there's Web 1.0, which is mostly read-only, where somebody will create the content, we can read it. There's no way to interact with it. And when it moves on to Web 2.0, there we can read and write, but most of the data will be owned by third parties like Facebook, Microsoft, Google, and all those big tech companies. And when it moves to Web 3, it is all independent nodes which are holding data. Independent node meaning we can place ourselves there. Each of these boxes belongs to us, and we are running a node in our system, and we can consider our system as a node in the entire network. And our system will have the copy of the data. That is the advantage of having Web 3, where we own the data. We are not sharing the data with somebody else. Is that clear? Just raise your hand if you have any question. Okay. This is clear, right? Yeah. So some of the core ideas of Web 3.0. Why do we need, I mean, as I mentioned earlier, why do we need Web 3.0 compared to Web 2.0? Because we need to have some ownership in the first place. The second thing is that it will have a decentralized setup, wherein rather than storing the data in a central server and giving responsibility to third party to control the data and manipulate it and then use it in whatever way they want, rather than doing that, we can have our data in our own nodes and we own it. That is the advantage of having this decentralized approach. Basically, these are all the points basically belongs to blockchain technologies. And then of course ownership and then security. Yeah, we can encrypt our data. Whatever you feed into blockchain, that will get encrypted automatically, and we can of course use our own encryption technologies to encrypt the data so that we can prevent it from accessing by some hackers or some other persons who are doing some malicious activities. Yeah. And then transparency. Yeah, because if you know if you have some concept of blockchain, it is all stored in a public ledger setup, right? So the entire blockchain is a public thing, and then whatever happens to the blockchain, or whenever you add some data or whenever you modify something to the blockchain, it is all transparent. It is all visible to everybody, and then there is no manipulation or anything that is possible within the blockchain. That is the advantage. Is that clear till now? Yeah, I think I missed one slide here. Before moving on to this, actually, when you discuss about any blockchain technology, there will be some words that you will come across, like for example, DAOs, decentralized autonomous organization. Anybody heard of it? DAOs. These are all some new things that are happening in the industry, especially with respect to blockchain and related technologies. DAO is something like there is no a legal entity you can consider as any legal entity. Currently, how an organization is running, you will have a CEO on top, and you'll have different managers under that, and there will be a lot of workers under that, right? So that is how it is working currently. But let us suppose a situation where there is no CEO, and everybody in the organization has some voting power. And whatever be the decision that is made by, or whatever be the decision that we need to take, it is based on an voting setup. If you has got some 20 votes and then somebody else has got 40 votes, then the other person can have more priority over that. But still you can participate it. That is the advantage. It is not like somebody sitting on top making all the decision and then pushing it on top of you. It is not like that. Just imagine a situation where in your college there is no principal. What will happen? It will be cool, right? But it is not like that. This is applicable for a legal entity. Okay. And yeah, another thing is NFTs, non-fungible tokens. That anyone heard of? Probably no. That is actually you can treat any digital asset or any asset, like for example art or music or any creative assets, that we can put that in the blockchain and then create a unique ID, and then we can say that if you have this unique ID, then that is the authentic thing. Currently, if somebody show you a picture of Mona Lisa and then claim that this is the original Mona Lisa painting, how will you make sure that this is the original thing? You'll have to trust him, right? That is the only thing that you can do. But if somebody put that thing into the blockchain and then create a proper validating certificate, then that is the original thing. You can believe it. Because you cannot simply put something into blockchain and then claim that it is the actual thing. No. There is a verification process and all those things, and after that, you will be issued with a certificate. So that digital certificate has got a lot of value. So this general setup of converting these creative assets into some digital thing in the blockchain is called NFTs. I'm just saying that in a lighter way. It is not really the actual definition of NFTs. And another thing is smart contracts. I'm just saying two, three words because you will come across these words anyway if you do something in blockchain. Yeah. Another thing is smart contract. Even if you, what is this contract, by the way? We can make this session interactive rather than you guys sitting and listening and then I am talking always. It's not the right thing, right? You can ask questions. Yeah, so smart contract is, even if the name says that it is a contract, it is not really a contract, it's a program itself. Yeah. So any software will have its own coding language and underlying programming setup, right? So smart contract is a program where we write our code and there will be a lot of conditions that are written in the code, and through that condition we can limit access to a particular resource. For example, we discussed a scenario of this creative assets, right, using NFTs. Right? You have created a picture and then you uploaded that to public blockchain and then claim that that is my painting and this is the original validity certificate of this. How will you make sure that that is the right thing? You will have to write some program, right, to make sure that it is nobody is tampering with it, and I have some identity with me and that is protected using some program. So this program that controls the access to different resources in the blockchain, and it controls how you interact with the blockchain, is called smart contract. It is a program, just keep that in mind. It's not a contract or any paper stuff. Okay, clear these three terms? I have discussed about DAOs, decentralized autonomous organization, NFTs, and smart contracts. Clear? Any questions till now? Come on. You can ask anything, even in Malayalam, it's okay. Okay, I'll move on. So this is, this slide looks a bit busy. There are a lot of pictures and a lot of things over here, but what it discusses that how a typical entry into blockchain works. Blockchain, we can represent blockchain something like this. It's a set of nodes that are linked together. So in computer science parlance, a set of nodes that are linked together, what is it called? Computer science parlance. What is that? That's a linked list, right? So basically you can view this blockchain as an advanced linked list. Yeah, linked list you guys are all familiar, right? In data structures. Yeah, it's an advanced blockchain is basically an advanced linked list where you have all these controls, like you have encoding, you have security, you have protection, all those things. Yeah. So this is the blockchain representation, and then what is represented here is that, okay, if you want to do a transaction or if you want to share some asset with somebody else, then actually you will have a smart contract written in a language. This language that is shown here is called Solidity, which is a specific. I am not going into that detail, but you can always go to YouTube and then find out what this is. This is called Solidity. This is one of the language in which we can write smart contracts. And like you do Java program, you might be familiar with Java, C, C++, right? So after writing the code, you need to compile it, right? So that it will get converted into bytecode and then system can understand it, right? So like that, after creating the smart contract, you convert that, you compile it, convert that into bytecode, and then how a typical, maybe I will skip to this slide, yeah. How a typical blockchain network, or when you connect with Web3, you need to connect to a blockchain network, right? So how this works is, you will have an interconnected set of nodes. You can assume that this is you. This is your computer. And you are running a node, and that node is connected to the entire the blockchain network. Yeah? So we can call that as a virtual machine, which is running. You have heard of that virtual machine concept, right? A virtual machine that is running some blockchain node locally. Yeah? That is called this EVM. EVM, E stands for Ethereum. Ethereum is one of the implementation of blockchain. Ethereum you might have heard somewhere. Yep. So that is Ethereum virtual machine. This means that somebody is running that in locally, and then he is trying to push his intent to do some transaction through the smart contract into his local. And then what will happen is it will get pushed to the entire or the main blockchain network. And when you push something to the blockchain network, you can push anything. There is no validation or anything, you can push anything. But we cannot accept it straight away, right? Say if it's a banking transaction and if you are trying to make some fraud transaction, so can we accept it automatically? No, right? So there should be a mechanism in which a set of people should observe or should check this particular block. What you are trying to do is you are trying to add a block into the blockchain, correct? So before adding or before confirming a block into the blockchain, somebody should verify it, and then a group of people should approve it, saying that it is okay to go. Those set of people are called miners. They are actually having huge computer systems, and then they download the entire blockchain thing into their system, and then they do this calculation and then find out whether this block is correct or not. Just think about it. Like if you are doing something on a public blockchain network or public ledger, that is what is this blockchain thing is called. Just think about its size. It's going to be huge, right? It's a huge data setup. So you cannot download the entire thing into your local network and do this mining. So to do this mining, you need a big computer setup. That is why there is a separate group of people called miners. They actually validate your token or your block, and then they will confirm that, okay, it is good to go. When they confirm it, they'll get added to the blockchain. And then the corresponding transaction will get executed. Is that clear? Maybe it's a bit confusing. If you guys have any questions, we can discuss. It is just like any other system, right? This block diagram looks very simple, but in the background there are a lot of things that are happening. Clear? Okay, yeah. This is another representation of the same thing there. Somebody want to, this is the owner of some digital asset or some creative asset. He want to create a smart contract, and then he want to register it in the blockchain. And somebody else want to use that or rent it through the blockchain. That is what is depicted here. So all these interactions will happen through the smart contract. Smart contract, if you remember, that's a program. It is not a contract or paper or anything. It's a program. Through that program, we will validate whether that is right or wrong, and then through that program, we will give access to the renter. That is what is depicted here. And then this is a simple code fragment. I just put it for just making sure that it is a program. Yeah. It's not a. I mean, when we say smart contract, you can assume that as a simple Java program. It is not a complicated thing anyway. This is clear, right, till this point? And again, yeah, we have in all these things, we have assumed that Ethereum is the blockchain implementation that we will follow in this session. Yeah. If you go ahead with some other session or some other implementation, then probably you will have different names instead of a smart contract. You will have different name. Yeah. But fundamentally, this is what is happening in the background. Yep. Yeah. So when we move to Web3, what is Web3? By the way, I have talked about blockchain. I have talked about a lot of other things. Then, what you understood, or what was your take on Web3, Web 3.0? Is it the blockchain? Then what's your understanding on blockchain? Or what's the understanding on Web3? How is it different? Web3, if you look at it in this diagram, it is actually an interface or a framework that will enable your program to connect to a blockchain network. That is what is shown here, right? It uses a protocol called JSON RPC. It is something similar to, have you guys heard of REST or web services? It's something like a method call. We make a method call to another system. So this is a typical protocol that we use when we connect with a blockchain node using Web3. Web3 is a JavaScript framework. You can simply think it like a JavaScript framework. You can import it into your code, use Web3 to connect with the blockchain network. Is that clear? It is not exactly the definition of Web3, but I'm trying to simplify it, and then so basically it is a JavaScript framework, and then you can use that and then connect with the network. Yeah. So what it enables here is you can now connect your web application to the actual blockchain network. Yeah. There are a lot of initially I thought like I will share or I will discuss some demo with you, but then I decided, okay, there is no point in doing the demo because anyway a lot of tutorials and all those things are there in YouTube and Google. You can go and refer it, and that will explain better than me anyway. So you can go and research on that, and then this link will give you a decent understanding on how you need to implement Web3 typically. I mean, it is not the standard way to do it, but you can refer it and then do it. These are all some of the real-world applications that are based on Web3. When I say Web3, it is fundamentally backed by blockchain. So Storj is actually a decentralized storage solution. Rather than storing your entire thing over the central server, you can store that in a decentralized way. And DTube is something similar to YouTube. And yeah, Brave browser, and I'm not going to explain all of these things. So, what is your take on Web3? Is it okay, or is it something similar to the thing that you are doing earlier in web? Do you have any web development experience? Right, you have it, right? So compared to that, will you try to do this Web3 after going back home? You can do that. I mean, you're going to have your college projects, right? You can try and choose some projects that are to be done in Web3 and then try to do that. So yeah, so Web3 is still in infancy stage. It is not yet a fully functional or a fully developed stage yet. So we will have to have more apps and more things or more development that we need to do on top of Web3 to make it more usable in all the scenarios like we use Web 2.0 now. Yeah. So any question? I initially I thought like you will have a lot of questions, and then that is why I removed a lot of slides here. Do you have any questions? How are you going to implement Web3? Where will you use it? Can I use Web3 to implement a college website? Yes or no?
Hi sir, have you done any projects based on blockchain?
We have in one of my previous companies. We have done a prototype. It is not a real production version, but when we do that, there are we can of course talk about this like in a fancy way, like it will work, all those things and all. But when it comes to real implementation, there we will have a lot of challenges. Like for example, we when we approached one of the customers, their challenge was like they are ready to do this project, but they have a lot of small customers, their customers. I mean, we approached our customer and they have a lot of their customers. They are small in size. They don't have big money and all those things. So how will they create their own nodes? Do they need to buy a high-end system, or do they need to become a miner? So those questions actually raised, and then practical approach is actually not really running a node in every individual system. What I'm talking about is an enterprise level system, developing an enterprise level system using blockchain. So practically when you run it, actually you will have to do that in one of the hosted services, like for example Amazon EC2 or something else. It is not really possible to do that in the local node. Yeah, of course, to answer your question, yeah, we have done a prototype, and yeah, it is not in production yet. Yeah, any other questions?
Sorry, if we have Google account, if we have a Google account, we have data account. Indirectly data Google data Google exposed. Web3 our feature data access third party.
Web3 in fact all these blockchain setup Web3 in middleman why should we need to share our data with a third party? And data share data share actually we data listen add push level data share Web3 private data keep the difference is that currently Google is offering this service for free, but when it goes to Web3 or if you go to some blockchain based solution, it is not going to be free. If you look at this Ethereum scenario, they have a crypto or they have a currency setup called ETH. That has got some value. So if you want to do some transaction, you will have to spend some amount in terms of ETH. It is not free. That's what I'm trying to say. So as the miners, you might have seen this. this thing, right? The miners, they are the people who are going to run their hardware and then try to resolve these blocks, right? Or try to say that, okay, this is an okay block or not. So these guys need this ETH as an incentive. Yeah. So this money is for them. And if the problem that may arise is that, okay, you want to commit a transaction and you want to commit a transaction, and you are ready to pay more, and then the other guy is not ready to pay more, then the miners will pick your transaction first because you are paying more. That problem can arise, but fundamentally it is not free. Did I answer your question? Thank you.
Thank you, Sandeep sir. I would like to request Mr. Hari B. Nair, Director of Center Operations and XpertEaze Business Solutions, to kindly present a token of appreciation to Mr. Sandeep S Nair.